All right, I am definitely going to make sure that I record this one as I had trouble recording the lectures yesterday. One I remembered at the last moment, one I remembered about halfway through the lecture. So we're trying to do better today. We're going to go over a couple of things in this lecture, and I'm actually going to rearrange things a little bit. I'm going to first go over week 4 examples. In fact, I'll rename those. Week 3 and 4A. And I'll make these week 3 and 4B. Always a good idea if you have a chance to review these examples prior to the lecture. That can give you a preview and let you check out what's going on, and you can bring questions that you have to class. I had forgot to enable week 3 and 4, and I did that now. I do apologize for that. If you ever log into Canvas and you do not see something for the current week, please let me know. All right, so let's look at this first example that we're going to go over today. This example is to grade a quiz, or I'm sorry, my mistake, not grade a quiz, to calculate the gross pay based on the number of hours a person works and the type of job they are. All right. And we'll look at the code and we'll see how this works. All right. So for example, if I enter in 40 hours and the person is a manager, they make $600. And just for demonstration purposes, I put a gigantic check mark on the screen indicating that the data entered was valid. If they entered 40 hours and they are an associate, they get paid 480 hours, 40 hours, and they're a trainee, they get paid $400. There's also the question of overtime. Trainees get paid overtime, and I'm not sure if associates do. But I don't think managers do. So anyhow, let's look at the code here and let's see what's going on. Again, this is listed as week 3 and 4 examples A. So I'm going to bring this up. I'm going to edit it in Visual Studio Code. And by the way, you enter invalid data, like I enter some garbage here for hours and click calculate, I get a list of errors. All right, this shows that it's invalid. It puts a big X on the screen. It's invalid, and it gives me an unordered list of errors. So let's look at this example. First of all, the HTML. I have my form, text box for text hours, a radio button for the job type, and a button, not a submit button. We don't want to send this to a web server. We want this to simply trigger off some JavaScript. So we have just a plain old button that when you click it, it calls process form. We have a place to put the result. And then we have a couple of sections to show if there's any graphics, the graphic, which is either the checkbox or the X, and then finally a list of errors. So let's look what happens when we click process form. When we click process form, we do these things. Invalidate form. Notice that that doesn't say validate form equals something. Validate form is a function that returns a Boolean. Therefore, I do not need to say if validate form equals true. I can just say validate form, and if validate form returns a true, it'll do these. If it returns a false, it will return these. So let's look at, first of all, if it's valid, it's going to display the one image. If it's invalid, it's going to display another image. So we're going to call the function display image. And display image finds the thing on the page, or actually it creates a thing on the page called IMG. All right? IMG is a way to create a new, or create element is a way to create a new element on the page, a new image tag, a new link, anything like that. So what we're actually doing is, if you notice in the original example, there's nothing in the section with an ID of graphic. We're actually, through our JavaScript, creating a new element. And that element is image. Now that image tag, this is creating an image tag, and right now it's not anywhere on the page. All right? Right now it's not anywhere on the page. We are setting the attributes of this. We're going to set the source out attribute and the alt attribute to the arguments of the function. So if it's true, we're setting the source argument to valid JPEG, and the word valid for the alt, and invalid JPEG, invalid for the alt. So we've created an image tag somewhere in memory that looks like this. That very first instruction, create element, created in a variable called image, a tag. And what does that tag look like? It's an image tag. It's not a string, it's actually a tag. That's what this statement does. So we got, in our memory, in our machine's memory, we have somewhere variable called image, we have a tag object. Or probably better, more technically put, an image object. An element of some kind. We're then setting the attributes. So the first one sets the attribute to whatever is passed in. And in the case of valid, it's going to set the source attribute of this to valid.jpg. We then set the source attribute or the alt attribute to whatever the text was. So we have this tag and it's floating in space, and the reference to that tag is IMG. We're going to find where we want to put it. We want to put it in the section called graphic. So we pull up we set a location variable to be the location that we want to put the image in. And we get a pointer to that. So this line, this instruction finds the thing on the page with an ID of graphic, and that's this section down here. We loop through this and we remove anything that was in there before. Location.firstChild is any element inside that section. Now, initially, there aren't any. So this loop would terminate right off the bat. First child would return false because there are no children inside that. Again, when we talk about children of nodes in an HTML document, we're talking about tags that are nested inside. So we're looking at things nested inside this graphic. And again, initially there is nothing in there. So we can't pull up the first one. Therefore, this loop is false right off the bat. If there was something in there, for example, if we did this process once and there was a check mark in it, if we re-entered the data and it was invalid, we wouldn't want to have a check mark and an X. So we're going to loop through and we're going to remove the check mark that was in there before we put the X in there. We then append that child, that tag that we created an image, we put it inside this location. And this location, again, remember, is this element down here. So that append child actually puts in there that new image tag that we created. The next time around, we're going to clear out what's there, and then we're going to put the new image in there, whether it's true or false, whether it's valid or invalid. We're also going to create some text in there. And that's what this does. We grab a variable message. We create a message node or a text node that contains our message, and we add that also to location. So in other words, when we run this, the section, in fact, we put some style on the section. What's the section called? It's called graphic. Put a border on it so we can see where it's at. When we run this, there's that section. Nothing's in it. So that border is like really small. All right, there's nothing in that. There's no content in that section. So we're going to put in invalid data. Put in some garbage here. And I'm not going to select a job type. I'm going to click calculate. The first thing calculate is going to do is it's going to call process form. Process form is going to validate the form. And in this case, validate form is going to return a false. So what we're going to do is we're going to call the display image function, and we're going to give it invalid.jpg and the word invalid. So we create our image, we set those two attributes, we find the graphic section, we get rid of everything that's there. There's nothing there initially, so we don't get rid of anything. We then add that image tag to our location called graphic. We set a variable for message, we create a text node, and we append that text node to location. So when I click or calculate, I get within that the invalid and the message stating that it's invalid. If I put something valid in, I get the checkbox, and it says that it's valid. I think when I first did this, I was in a hurry and I didn't resize these things. So let me do that now. All right, we all know that we should save a copy of this first. But in the interest of time, I'm just going to edit it and save it. So that we have more reasonable looking graphics here. All right. Any questions about how that display image works? We're going over this a piece at a time. So we haven't looked at what validate form does yet, but we assume it's going to return a true or false, which it is. If it returns a true, we calculate results and we go and do this. If it returns a false, we do this. And that calls this function, which takes care of it. Now notice that, again, we could have put all of this code in the true and the false section, but that would have been repeating ourselves. So instead, we created a function that we could call and give the value when it's valid, give the values when it's invalid. And this takes those arguments and finishes it out. All right, let's look at validate form. We're going to show a different way that you can create HTML on a page. This is one way by actually creating the element, and it's probably the preferred way. But sometimes, especially if you're not doing a lot, you can use this method. All right. I set the inner text HTML, inner HTML I set to blank. That is this thing down here. I remove anything that was there. In other words, any error messages left over from a previous run, we're getting rid of. I assume that it's valid until I find an error. That's typically the way that you write validation, because the way it's easier to code it that way. Because if there's one error, there's a problem. Doesn't matter if there's any other errors or not. So it's easier to write the code to look for one error than to write the code to make sure that everything is correct. If you don't believe me, try and make the opposite assumption. Assume that the form is not valid and write code to prove that it is valid. I'm setting my error message, which is actually a UL tag. All right. I get the value from the thing on the page that has a ID of text hours. That is this thing here. Notice I have an ID and a name. The name is typically what is going to be used by the server if we were to post this to a web server. The ID is what our JavaScript is going to use. Just get in a habit, I would say, of creating both of them. We look to see if that hours when trimmed equals an empty string. What does trim do? It removes any forward or any spaces before or after data. So if I were to go space, 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 11, space, 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 I just want to do the calculation based on 11. And that's what it will do. On the other hand, if I put in a bunch of spaces and no data in, it's going to show me that it's invalid, that I must enter hours. So the trim command gets rid of any leading and trailing spaces within the string. So if there's nothing in the hours after I remove the leading and trailing spaces, I have an error. In my error message, I'm adding to it an li that says must enter hours. So now my error message is this ul plus this li. So I'm actually forming a string that's going to have my HTML that I'm going to put in that error area. Second thing we do is if that is not true, so if there is something in there, I'm making sure that the value is numeric. And if it's not numeric, I have a different kind of error. Notice when I run this, if I don't put anything in here, I get must enter hours. Or if I put in alphabetic data, I get must enter a value or must enter a number in for hours. So if I've entered something in there, this is not true. Therefore, I check to see if it's not a number. If it's not a number, I have an error. And this is my error message. Finally, if I entered a negative number, it's still not valid. I must enter a positive number for hours. So I have this if statement with some else's in it that looks at the number of hours that were entered in. Remember, a text box can be any string. So I test to see if there's nothing in there, if there's garbage in there, finally, if there's a negative number there. Then I call a function to get the type. Getting the type is going to look at this dropdown and pull the type. Now, when I originally wrote this example, that was a radio button. But right now, it's a text box, or it's a dropdown. So get type looks at the dropdown, grabs the value from the dropdown. It has an ID of RB type and returns the result. Here I have an alternate way of doing this. But when this is done, it's going to return the value that is in that dropdown, which will either be an empty string, an M, an A, or a T. Now, why did I make this a function instead of just putting that code in here? Because I'm going to use get type again over here. So I have my code in a couple of places, so I write a function for it. If there is nothing in the type, then it is invalid. And I add must choose job type into the list. So if I enter that in there and click calculate, I made this a list, so therefore I can see both of the errors. Must enter a positive number, must choose job type. So right now, this variable error message has a UL tag in it, and it might have one or two or no LIs. If there are no LIs, then this UL is empty. This UL is just the UL tag. It's not empty, it's just the UL tag. If there's one error, there's a UL and an LI. If there's two errors, there's a UL and two LIs. The actual HTML code is in there. I add my closing UL tag. So right now that string error message, again, is a fully formed, correctly formed LI tag or UL tag. Has a start UL, has either 0, 1, or 2 LIs in it, and has the ending UL. Now, I only want to display the errors if there are errors. So if B valid is false, I'm going to set the inner HTML to that error message. What that does is that actually plots right in here the value of that variable error message, which we formed as an HTML tag. Therefore, we see actual HTML appear in there, and that's how the browser displays it. If there's no errors, of course, and there's nothing to display, we're not going to display the empty UL, so we just don't display the errors. And finally, we return B valid, back up to who called it, and we either display image this way or that way, and if there are no errors, we call calculate results. All right, so when we click the button, process form, we do this, we get either a true or false. If it's true and the form is valid, we calculate and display the image. If it's false, we actually display the false image and the text saying it's invalid. So finally, we have calculate results. And again, I broke this down into several functions just to make the code clean. That's the second reason to create functions. If you have long, gigantic functions, if you have to scroll to see everything in a function, then that function might be too big. It's easier to break down the function, a big function, into smaller functions. That allows you to get your head around each individual part. So we grab the number of hours. At this point, we don't have to do any validation for hours. We've already done that. We wouldn't make it to here if there were errors. We assume that the rate is 0. We get the type, the function we had here. We get the rate, and the rate is based on the type of employee. So 0 if they're manager, $15 an hour. If they're associate, $12 an hour. If they're trainee, $10 an hour, and return the result. So now rate has their pay rate, and hours has the number of hours. So calculating their pay is just a matter of multiplying rate by hours, except for the fact that a couple of these get overtime. So who gets overtime? The associates and trainees. So we have an if statement that asks, is the type equal to A, or, that's what these two vertical lines mean, sometimes called the pipe, or is the type equal to T? So in either of those cases, we're going to execute this, and we're going to add an extra 50% on for all the hours over 40. So if they work more than 40 hours, we subtract 40 hours from that, and they get an extra 50% of that rate. So trainee and associate get their regular rate for their first 40 hours. They get time and a half for their second 40 hours. And we then have that variable in gross pay, and we simply set the value of the inner HTML of result, which is somewhere over here, into this span. One of the points of this example is to, how do I want to say this? One of the points of this example is to show how functions can be used to really simplify the project flow. You could probably write this as one gigantic function, but that function would be a mess. All right. In the old days, we called things like that spaghetti code. You know, it's just hard. When you look at it closely, it's really hard to tell what's going on. What thread leads to what path leads to what result, and so on. It's much better to write these in clear, distinct functions. Each function just performs a little bit of the task. And then strung together in the proper sequence, it fulfills the entire task. Other thing we did is we saw how to pull values from different form controls. Pull from a text box, you simply say document get element by ID dot value. To pull from a drop down, you would just say document get element by ID value. Now let's see how easy it is going to be if we change this to a radio button. Because again, originally this code was written for radio buttons. That's why that thing is called RB. So let's go and let's change our HTML to be a radio button, or a series of radio buttons. Now this is going to also have a name and ID. The difference is going to be that for radio buttons, the name and the ID are different. The name is what we use to group together radio buttons. And I'm going to do this a little bit sloppy. I'm not going to put my labels in. Actually, no, let's put the labels in. We'll give a good example to you. The label uses the ID. Accessibility is important. I shouldn't just fluff it off in the interest of time. And you see, if you notice, this is not really that hard to do. All right, let's go and get rid of this. I think my code is all correct. Now, what do I have to change up here? All I have to change is a get type. And since it's a radio button, we access radio buttons differently. So I'm going to say if document RB manager forgetting how to do this. Not checked. That is checked. If it's checked, our value is the value of that button. So we get the value of whichever one got checked. Return that. Notice we only have to change it in that one place. That's the only place where we get the type. And if we save this, type in 11 manager, we get the correct amount. That's 15 hours, $15 an hour for 10 hours is that. We do associate, that should be 120. We do manager, it should be that. If we start with nothing, it gives us an error. You must enter job type because the job type would be blank. All right, so lesson 1 from this, breaking down a big process into multiple functions. I've heard it said that a function should be about as long as your screen to edit it is. Well, again, our screen is a little bigger than normal. But if we make it smaller, our largest function is validate, and it's slightly longer, but I could get rid of some blank lines, I think, and make it fit on one page. That way you can see the entire function from beginning to end without scrolling. So that's a good guideline to have. Function equaling one page worth on your screen, one screen worth on your screen. calculate result. We can see it from beginning to end. Get type, beginning to end, get rate, and so on. Important concept, not just in JavaScript, but in any programming. Sort of the divide and conquer strategy. Take one big problem and separate it into multiple smaller problems, and then handle each one of them. One thing that you can do is you can actually fake it until you make it, as they say. If I was having trouble writing the validate form, or if I wanted to do the calculation before writing the validate form, I could simply just change this function and say return true. And we're going to pretend any data I enter is valid. Now we know we're going to have to fix that eventually, but I can do that to start working on other parts of this program before I'm done with the validate. So some of the advantages that you get when you take this divide and conquer strategy. Notice how things are properly indented to indicate nesting. If they weren't, then these loops, these if statements, functions where they begin and end, would all be very difficult to determine, and you'd have a hard time maintaining this code. Remember, maintainability is one of the things that separates code that works from better code. All right? Breaking into functions, indenting properly, all those things make it easier to change when it comes time to change. And it's a fact of life that pretty much any code that you ever write is going to be needing changed at some point. You know, in this example, maybe there's another employee class added, you know, supervisor. That's between manager and associate. That has a $13 pay rate per hour. By doing that, we only have to change a couple of things in here. And we know exactly where to go to change them. We'd have to change the get type. To change it there. And would have to change it here to calculate rate. The rest of the code would maintain exactly the same. And you could change it quite easily. All right, notice how we pulled data from the form. Notice how we put HTML on the page, either by creating an element and making that, adding that to a container on the page, or by using the inner HTML. Both of those are approaches that can be used. So take a look at this. All right. Next time we're going to do example B. All right. Which is going to show some additional things. We'll review some of the contents here, and it will do some additional things as well. Are there any questions? All right, give me a few minutes to get up into the lab, and then if you have any questions, you can see me up in lab. We'll see you next week.